So recently I've been looking into making my own STM32 development board, something that I could use just to test things out, slap it on a breadboard, but also if I wanted to implement it onto, say, VeriBoard or another PCB, I could just easily solder it in and I can just immediately use it as is. And so I thought, instead of just using those generic STM32 black pill, blue pills you can find all over the internet, I wanted to work with, or at least try play around with, an STM32 chip that you couldn't easily get as a development board just off willy-nilly on the internet like Amazon. And so I decided to doom scroll JLC PCB and look through their STM32 catalog. Gave me a few suggestions, but ultimately I came to one which was the STM32G031 G8U6, yeah, which essentially is a very, very small STM32 microcontroller. It's a 3x3mm chip, and it has 28 pins, and I know there are a lot of chips out there that are like just as small, like I think the CH series, CHV003s, 592s, those ones are pretty small as well, but for the time being, I only have an ST-Link V2, so I'm going to stick with the STM32s for now and maybe move on to the more feature-rich ones later on. So yeah, the STM32G031, G8U6 in particular, has around 64 kilobytes of flash memory, which I guess isn't too surprising in this day and age, a lot more than the usual 32s you'd see in your Arduinos. But yeah, definitely you can attach a lot of peripherals into it before you start burning through all that flash memory. It's 8 kilobytes of RAM, SRAM, which I guess is more than enough. 2 I2C lanes, it has 2 SPI lanes and 2 USART lanes, especially with one low power UART lane. It runs up to a frequency of 64 megahertz on its chip, which again is still pretty good compared to your classic Arduinos. Nothing too surprising, I guess, but yeah, it's really cool. Like I mentioned, I want this dev board to be usable not only on a breadboard, but also directly integratable into, say, a PCB or a variable. So ideally, I want this to be as small as possible to leave as little of a footprint, but also I kind of want all of the GPIOs exposed, at least all of the ones that I know I'll be using exposed, so that I have the freedom of picking through all of them if I need to. So that's going to really limit the size based on how many GPIOs I can expose. Another thing I wanted to add into this is that I want it to be breadboard seatable, so something I can directly press into a breadboard. That's just for this iteration. I know I could definitely make this smaller if I didn't do that, but it's going to keep this very, very simple, you know, first iteration. Thanks to using the UFQFP-N28 package, there really isn't much to connect to this microcontroller. I think the main things I'm going to expose are, of course, the serial wire debug pins. I'm going to have all the general purpose I/O pins just branched out to the side, and I think I might use one of the UART pins, or in this case the USART pins, USART 1, in case I have any peripherals that do use UART. Yeah, there really isn't much. So the main key points here is the header pins, of course, to expose all the required pins. And then there's the low speed clock, so the LSE, low speed external, which is a 32 kilohertz or 32 point something kilohertz chip with the appropriate capacitors on each side. The UFQFP-N28, they don't support a high speed external clock. Yeah, that's fine. Don't think I really need it anyways. So we'll only be using the low speed external. And I don't know why they call it low speed external, because hell, I'd like to see you count 32,000 times a second. But anyway, I digress. We're gonna have the reset pin, and then of course attach some random capacitor there. 100 nanofarads should probably do it, just to do bounce it here and there. I'll have it in the pull-up configuration like it always asks, and no boot pins, so no need for a button for the boot. I think the serial wire debug handles all that. So the microcontroller has the appropriate decoupling, of course using a 4.7 microfarad and then 100 nanofarad. This is just according to the datasheet spec. I'm pretty sure I could have just added a 10 microfarad as well, but honestly I didn't see the need for it. I did add a 10 microfarad input decoupling for the serial wire debug, and of course I won't be using a low dropout regulator. The serial wire debug, or the ST-Link V2 itself, has a 3.3 volt output, which I'll be using directly to power the entire chip and all the peripherals connected to it. I'm pretty sure it should handle it. They don't draw that much current to begin with, so should perfectly be fine in most use cases, I think. Yeah, that'll help me reduce the component count, which I guess makes it easier for me to make it as small as possible. So yeah, That's it. Not very much on this board, which I guess that's a good thing. Do want to note that I'm not putting any test LEDs or status LEDs on this, just to again reduce the amount of components I need. I can always do that externally if need be, or I can always like include that onto whatever I'm designing as well, if it's a PCB or another variable. Yeah. PCB design. Cool, that didn't take too long, especially since there wasn't any components, or at least that many components to work with. Final dimensions I got the board to is approximately 18.3 by 31 millimeters, which I feel like I can go smaller, but I'm not gonna get ahead of myself, especially since I'm still pretty much an amateur in all this PCB design kind of stuff. I am using a 4-layer board for the sake of having 2 ground planes in the middle. Everything goes on 1 layer. Yeah, there really wasn't much to like move around, so it did give me a bit of like wiggle room for everything to properly seat capacitors to as close as their source as possible, to move my low speed clock aside, to have my pins just around everywhere. Key point I wanted to note that I am not using any USB connection here. I can obviously do that externally with some USB to UART kind of chip, but since this is programmed via the serial wire debugger, I honestly didn't see the need to have a USB port directly onto this board at least. So with all that, just gonna slap some silk screen. So just labeling all of my pins and then slapping the date I finished the board. So then you can compare. This is the date that I finished the board and I decided to send off to JLC, and whatever the day is right now that you're seeing this is how long it's going to take me to edit all of this and get it all ready. So if I've been procrastinating, then you'll see a jump in the month gap right here. But yeah, I should probably get back to work for at least another 2 weeks, because that's how long the PCB will come. But dang, these side quests feel way more thrilling when there's like something due soon. Yeah. 2 weeks-ish. Cool. It's here. So look at that. I can zoom in just a little. Just a little. There we go. Look at that. That's so cute. I did go and get most parts pre-made on it, especially the SMD devices and the STM itself. The header pins I'll do it myself, same for the push button, because I conveniently have it on hand and I can solder that, but everything else I can't solder by hand because, well, I didn't have a hot plate. So yeah, maybe that's something I should look into, because I think that would have saved me a lot more money. Yeah, this is it. I'm gonna quickly solder some stuff on it, and yeah, here it is, with just the pins, I guess, and the button. To editing this, yeah, he started this like last month. It's April now. Yeah, I wonder how long it'll take for me to finish this video. Anywho, yeah, I gotta go test this real quick. So, I have the board connected straight to my desktop, and of course, the first way, or the best way to know if it's even working, is to look at STM32G0 programmer. I have it connected here, and it's linked, and you can see in the bottom right here, it says STM32G03X. That is exactly what we chose, and flash size 64 kilobytes. So, just from the serial wire debugger, looks like everything is connected. The chip is in fact being powered. What happens if I click the reset button? No, I don't think that actually shows up. Well, I'll know when I flash a program into it to have a look. Cool, so what I have here is just some generic SSD 1306 library that I've just moved into the program here. And then I've just made it so that it'll display the word walnuts for the first 2 seconds, and then have a number on the screen update and increase by 1 every 100 milliseconds or so. So it'll just be counting up. Cool, so the program is running and you can see that the numbers are counting up. I'm going to quickly press the reset button right here. And there we go, we've got the walnuts, 2 seconds, and then we've got a number that counts up every 100 milliseconds or so. Yeah, so I2C works, and yeah. One common thing I'll be using this DevBoard for would be for PID controls, or just general control systems anyways, for like very, very basic things. And so what that would need is usually some kind of PWM generation here and there, whatnot, what forth. And so what I have here is just some basic PWM generation. It's going to be generating some 250 Hz signal that's just going to ramp up from 0 to 100 all the way back down to 0% duty cycle. And if you look over here, what we'll see is focus, yep. We'll have right now a 250 Hz signal with a voltage of 0 to 3.3 volts, which is what the serial while debugger is giving the whole system. And you can see the duty cycle, I don't know if you can see the duty cycle on the screen right there, is ramping up from 0 to 100 and then back down again. So yeah, looks pretty good. The PWM signal looks pretty clean, or at least clean enough for what I'll ever use it for, so yeah, doing pretty well. And that's it. A very, very simple and I guess relatively small STM32G0 development board. It'll handle the majority of my breadboard tests since I deliberately made this breadboard embeddable. But yeah, now that I finished this, I feel like I can go smaller. I honestly think I can go a lot smaller. Something as simple as like maybe even getting rid of the push button for the reset pin, and then maybe just choosing a select few pins that I want to use instead of having all of them exposed. Yeah, even excluding the serial wire debuggers and the UI header pins, just using the exposed pins themselves as is. I feel like I can make this way smaller. For now, this is going to be my main workhorse, at least most for like very, very simple I2C testing, or even like PID controllers if I do need something simple. The amount of RAM and the amount of flash storage in here is nothing super amazing, but it'll handle a majority of these tasks. And so now that I know that this actually works, I can probably even solder this down onto further designs, variaboards, PCBs and whatnot, what forth. Or I can probably just copy and paste all the component layouts onto whatever I'm working on next. So yeah, good on it. Now that I've got this done, it kind of makes me want to try other microcontrollers as well. I do know that the microcontrollers like the CH592 are probably just as small, if not smaller, and they also have other stuff like Wi-Fi support and all that. So that would be really cool to look into. Or even just the ESP series, so the 8266, the 32s and all that. Maybe I can try work with something that's like internet integrated applications and all that. But honestly, I need to sit down and like plan all this. But I need to sit down and edit all this first. So till then, I guess, till then. Yeah, today is May 16th. So board was printed on March 30th. Holy, okay. Yeah, gotta work on it. All in all, yeah, I don't think I've ever done anything quite like this usually. I guess if you're interested, I'll leave a link down below for everything that I've gone through regarding this little chip. Honestly, there isn't much. Again, component-wise, there isn't much. Design-wise, there isn't much. And it just follows the same layout as any microcontroller DevBoard design. So yeah, honestly, if you're just curious, it'll be down there. Knock yourself out. Let me know what you think. Till then, I'll see you around.